Thanks everybody so far who's joined us. Thanks David and Varun for joining us. Really excited to have David and Varun with us today. I think between the two of them, tons and tons of cloud experience, obviously specifically most recently with AWS over the last sort of 4 or 5 years, but obviously I know Oracle experience before that and things like that. So we're really blessed to have two absolute cloud experts joining us this month to talk about Amazon Aurora and obviously everything that's happening that's new and exciting there. So you didn't come to hear me talk, you came to hear these two. So I'll turn it over to you guys. David, Varun, thanks very much for joining us.
Happy to be here. We should probably start with some introductions. I guess I'll go first. Hello, everyone. My name is David Bayard. I'm a database specialist solutions architect here at AWS. I've been at AWS about 4.5 years. Prior to that, I worked a couple decades at Oracle, so a long time Oracle person prior to AWS. What I do at AWS is I focus on our managed database services, things like RDS, Aurora, DynamoDB, DocumentDB, and a handful of others. I'll turn it over to Varun, and you can introduce yourself.
Hello, everyone. My name is Varun Mahajan, and I've been working with AWS for 4+ years now, and very excited to be here. And David and myself do regularly speak at the Philly Meetup as well. So this is our first time, I think, speaking for the Lehigh group. So very excited. And so past experience, so generally I work as a cloud architect. So I go a little bit more holistic. So not only from the database perspective, I dive into a little bit of analytics, a little bit of IoT, machine learning, and other aspects. But prior Oracle person worked onto the Oracle side of the thing. So definitely happy to be here, and nice to meet you all virtually.
All right, thanks, Varun. I think I will kick it off. Again, this is David. We're pretty informal here, so if you do have a question or a comment, just shout it out, or I see there's a chat function, so you could also type it in the chat if you want. What we're going to do to help be sort of interesting is we're going to talk about a couple of new innovations to our Aurora relational database. I'll briefly explain what Aurora is if you aren't familiar with it, but perhaps some of you who've been using AWS are familiar. So we're going to focus on some new interesting features that got added to Aurora, and then we're going to follow it up. Varun's going to lead us through a demonstration of one of them. So that's basically our agenda here tonight. So let's just jump into it. We're going to be talking about our Amazon Aurora service. Aurora is part of our RDS, or Relational Database Service family of offerings. But essentially, Aurora is sort of a hybrid between open source databases that people love because there's no need to mess with, commercial licensing or paying annual support and all those pains. But it's also sort of mixed with some of the abilities you would only see in traditionally, not in the open source databases, but in the commercial databases. These abilities are things like high availability, durability, scalability, extended DR capabilities. And these are the kind of things that what we did with Aurora is we sort of took the MySQL and Postgres engines, and then we melded them with a purpose-built cloud native storage layer that we call Aurora. And it's that cloud native Aurora storage layer that gives us some of our special benefits. Like at the high ends, when traditional architectures might start bottlenecking, we can keep scaling out with the Aurora storage. And that's why you see, we can do up to 5x the throughput or 3x the throughput compared to some of the standard open source offerings when you get to that extreme. We're also very durable. The neat thing about Aurora is we automatically, for every block of the database, store 6 copies of the data spread across 3 availability zones in a region, which is incredibly durable. It's also incredibly impressive to be able to do that while we're constantly taking reads and writes to the database. So that's what Aurora is. What I want to focus on, excuse me, is not necessarily the basics of Aurora, but just talk about a few new features that have recently been added. Excuse me. All right, first thing I'm going to talk about is what we call managed blue-green deployments. So the idea of blue-green deployments is that the blue-green deployment approach allows you to keep an application sort of running and left unchanged so it can keep running smoothly in sort of environment we'll call blue. Meanwhile, you prepare sort of a change that otherwise would be perhaps big or disruptive in a green copy of the environment. And then at the appropriate moments, when everything's ready and people are happy, you switch quickly from the blue to the green. Now, for app tiers, that's stateless app tiers, relatively easy to do. When we're dealing with stateful databases, this actually is a pretty complex, hard task. So what customers have been asking us to do is like, is there a way that we can just provide this as a feature, as a a managed capability, so they can just click a button in the console or call one of our CLIs or APIs and do it for them. So this is what we now have been building and now offer, and it's what we call Aurora blue-green deployments. The basic idea is you have your database cluster, which is sort of showing up here as this combination of a couple of database compute instances, the read-write primary instance, and some read-only replicas that help carry the load, all sharing what we call Aurora storage. Together, that is our database. It might be starting on a certain version, say Aurora MySQL and the 2.x versions. You might have a task in front of you, like you need to do a major version upgrade. Traditionally, major version upgrades for a database are pretty disruptive. You often have to stop the database, perform the major version upgrade, a task which, depending on how big or complex your database is, can literally sometimes take an hour or multiple hours. So no one these days wants to turn their application off for an hour or multiple hours while they do it. So this is where this blue-green database becomes very useful. What you can now do is you can call like an API that RDS provides, or use our web console and click a button. But our API is basically called create blue-green deployment. And when you call that, what we'll do on your behalf underneath the covers is we'll spin up a clone of your running database, and we'll copy all the database over to the clone, and we'll keep it synchronized as data changes happen. So your application is still running. People are still able to do full functionality reads and updates and everything. This all happened against sort of the original database, what we call the blue side. Meanwhile, we've created, after you invoke this create blue-green deployment command, a green copy of your database that is now being kept in sync with all the inserts and updates and deletes that your application is doing. The beauty of this is that you can now do the heavy disruptive changes that you didn't want to do against the running application environment. That can include things like major or minor database version upgrades. It could include some certain types of schema changes in the database, or maybe you're doing some other maintenance that's somewhat disruptive or would require a relatively longer set of downtime performed. All that you can now do nicely against the green environment, sort of to the side, while you keep that application running. Here we're showing an example that you might do a major version upgrade. This is a classic use case for blue-green deployments. And we're going to switch from the 2.x series to the 3.x series. And you could run that While the major version upgrade of the green environment's going on, we'll pause the data synchronization, and then when it's done, we'll continue the data synchronization where we left off. Then, once your upgrade's done, you can do certain testing to make sure you're happy. And then at a moment of your convenience, maybe the following weekend, when you're ready, the app team's ready, then you can call our next API, which is called switchover. So you tell us you're ready to switch over. And what we'll do when you give us a switchover command or click the button is we'll validate that the clusters are in sync, that they're at a point where it is safe to switch over, like you're not going to lose data or miss changes. Once we get that validation done, what we'll do is, since we control this thing called the endpoint, which is how your application sort of connects to the database, we can actually remap the endpoint automatically so the same endpoint now points to what used to be the new green cluster. So this idea of being able to give us a command, we'll validate that we're ready to switch over, and then do the switch over, including rerouting this thing called the endpoint for you, makes it real easy to do the switch over without disrupting or having to go back to all your applications or app servers and do things like change host names. You don't need to do that with this approach. When we're done, what we do is we'll leave the old blue environment around. There might be a need for it. You might have certain uses, or just as insurance, you want to keep it as a fallback plan. But when you're finally done and satisfied that things are going good, you can call one last API, which is called delete blue-green deployment. And when you call that, we'll go ahead and delete the old environment for you. And that way you'll be set up so that, you know, maybe a year later when you do the next major database version upgrade, you can start the whole process again. So that is one new feature that people have been very excited about, the blue-green, managed blue-green deployments. That's currently available for our Aurora MySQL database, and it will be coming out shortly, maybe a month or two, for our Aurora Postgres database. The next feature I'm showing here is Redshift integration, but you'll hear us talk about it more likely as zero ETL. In fact, this is the feature that after I'm done with my section, Varun is going to do a demonstration for you. The reason why we have this feature, if we step back, is, you know, our Aurora databases are typically done to run applications. You can sort of think of them as transactional style databases for the most part. You can certainly build data warehouses and data marts in Aurora, and people do, but largely what we see is that people use Aurora for running analytics against the operational data store itself. The challenge with that is, well, starting from the bottom up, is if I have one Aurora database working for application A and I have a different type of application that's using a different Aurora cluster, how do I run a report or a query that combines data from those two things? You know, there's ways you can do, you know, essentially database links, but then those are a little bit messy. They're maybe not the best performance and so forth. So you have a challenge that you might have multiple apps, each with multiple databases, and how do I combine the data? Also, depending on what you're doing, some people, when they think of analytics, they want to have all of their data in one place, sort of a massive data warehouse, enterprise data warehouse, or data lake. And that can be hard with Aurora when you really get to that scale of petabytes. At that point, you know, when you're talking like petabytes that you would see like maybe in a gigantic enterprise data warehouse or data lake type approach, you're better off using what we would call like a cloud native data warehouse, something like Amazon Redshift. And the reason why is that these cloud native data warehouses like Redshift are built with that use case in mind, that sort of massively parallel processing approach to be able to deal with data volumes anywhere from, you know, hundreds of gigabytes to terabytes to literally petabytes of data. So what people typically do is we'll see them take their operational databases like Aurora, and then they build this thing you might call a data pipeline so that they can essentially ETL, if you're familiar with that term, ETL, data out of the transactional database and into the analytics environment. The trouble is customers don't like this because building and managing this data pipeline, these ETL jobs or whatever, gets to be a pain. They just want to write queries on the data, but instead they have to do all this care and feeding development of just getting the data from point A to point B. So hearing that and trying to do better, we've come out with functionality we call Amazon Aurora Zero ETL integration with Redshift. And what this is sort of like an easy button. You set it up in the console or the CLI, telling it, essentially, this is my source database. My source Aurora database is my target Redshift database. They could even be in different AWS accounts, and we'll do all the work for you. And that is great because in near real time, changes that happen here on Aurora can be immediately available in your Redshift analytics environment. So I think I've hit a lot of these. People want to get out of the need to build and maintain and troubleshoot their own custom data pipelines. So having something that's easy and reliable is very useful. Low latency, near real time arrival of data is also very useful. And then another subtle thing is with this Redshift environment, it can be a great consolidation point. So you, again, might have that scenario I described of multiple applications, each with their own transactional database, but they can all feed or come together in a single Redshift environment. And that way you can join HR data and financial data and whatever else you need to join. I'll talk briefly about how it works. You'll see some of this also in Varun's demonstration. But essentially, we have our Aurora database on the left, our Redshift database on the right. You'll go into our console or use our CLIs and define the integration, which basically means you tell us which source database, which source Aurora database you want us to work with, and what destination Redshift data warehouse you want us to write to. Once we have that information, what we're doing is a couple things. First off, we're taking advantage of some of the internals of how the databases work anyways. So a database like Aurora MySQL, it's writing its transactions to a log, it's capturing CDC information. You might hear of things like bin logs in MySQL and WAL files in Postgres. So we're piggybacking on that. But we don't necessarily need to know that because we're responsible at AWS for sort of making it all work and making it happen. First thing we need to do is seed the data because there's probably already data in your Aurora tables. We need to get that over there. So we have a clever way of doing that. We'll actually copy the data sort of to the side of your running cluster. So we're not going to tax or take any of the compute processing power of your running Aurora database to do it. We'll use our own resources and move the data over for that initial load of those tables. Once that's done, then we'll essentially implement what's called CDC or change data capture. And again, we built this such that we're taking advantage of our underlying Aurora storage technology so that we don't tax our customers' databases, our customers' database compute instances with any extra load. We can do all the work we need to identify and transmit the changes all at our level so that you're not paying a penalty or losing some of your performance. Perhaps even more important than just getting it to work when skies are sunny, is a lot of the complexity with things like data pipelines has always been things go bump in the night. And therefore, customers who are building their own data pipelines had to spend time building troubleshooting mechanisms or recovery mechanisms to get things back in sync. Well, since we sort of manage both sides of this equation and we manage this zero ETL, we can build all that in. So you don't need to worry about that. And as necessary, we can read seed tables. Say, for example, a customer alters an Aurora table in a way that we need to fully repopulate it. And there's a few cases where that happens. We do the needful, and we'll do that. We have lots of built-in automatic monitoring. And when the monitoring detects, any problems, we have algorithms that kick off to sort of auto fix the whole sort of zero ETL process. So again, these are all things that our customers were building on their own, and they really didn't want to be in that business. And so zero ETL is very exciting because it can free up customers from that work. You'll see more of this when Varun goes into his demo, but this is something we're rather excited by. Today, zero ETL for Aurora is in public preview for our Aurora MySQL version, and we should see it for Aurora Postgres towards the latter half of this year. All right, so we're moving along pretty quickly, which is good. We don't want to take your entire evening. Let's move to a third neat innovation called Aurora Serverless. So our full name is Aurora Serverless V2. We put the V2 in the title just to slightly differentiate from our original version 1 offering of Aurora Serverless, because we made some significant changes. Now, some of you might not be familiar with version 1, in which case it's a bit irrelevant. But if you are, or had a chance to check it out, maybe a couple years back, I really want to draw your attention to some of the things that are sort of unique with this V2 offering of Aurora Serverless. But the basic idea of Aurora Serverless is that it's an automatically scaling instance size. So when you provision like an Aurora or RDS database, typically what you would do is you would tell us the shape that you want for the database compute instance. And that shape would have a specific amount of vCPU, memory, and some associated like networking and IO bandwidth capabilities. That's all well and good, very predictable. The challenge with that provisioned approach is potentially you might have picked that size too big, in which case you paying for resources you might not need or be using, or you might have picked that size too small, and you are running out of resources, which means your consumers of the database could be waiting longer for queries to return, or applications to sort of finish certain tasks. So that's the challenge. You don't want to necessarily size too big. You don't necessarily want to size too small. The other challenge with the provision model is that while you can change the size, it often might require a momentary disruption of the database itself. In other words, sort of bounce the database or stop the database on one size and then start it back up on a compute instance of a different size. And that sort of stopping and starting would mean that the application would have a little blip where it couldn't connect to that instance and do work. So what's neat about serverless V2 is that it's automatically scaling and reacting to the workload that it sees. And so that means it can help eliminate that risk of perhaps sizing too small. It can also help you sort of take the worry out of what if I size too big? And if your size changes over the course of a day or course of a week or course of a month or whatever, it also means it can adjust without you having to sit there and sort of micromanaging the whole task. Let's talk a little bit about how serverless V2 works. The big thing here is that it offers what we call in-place scaling. What that means is that we'll grow and shrink essentially the compute instance on which Aurora runs on the fly, allocate more vCPU, more memory, more networking, and other capabilities if it needs to grow, and if it needs to shrink, or the activity on the database gets a little smaller, we can start to remove that, so you're not left oversized and potentially overpaying. To give an example, assume I have an application that uses an Aurora database. That application, for example, might be written in our Lambda technology. When there's only like a small number of Lambda instances currently accessing the database, well, then the database will be on serverless V2 relatively small in terms of allocated size. And by allocated size, I mean in terms of the vCPU and memory and network capabilities. But if more users start hitting the application, which spins up more Lambda instances all at once, the database will see that, oh, we're starting to get pressure on resources like CPU or memory, and therefore it will automatically start to grow. And it can grow and grow up to minimum and maximums, which you have control over. And then if people start walking away from the application and some of those Lambda instances are spun down, our database too can shrink back down. Basically, the way it works, if you want to peek under the covers, is there's this layer you don't necessarily need to know too much about called the router fleet. That just helps us pull off some of the magic. But when I have an Aurora compute instance, in the compute instance in Aurora, you can have anywhere from 1 to 16 compute instances that share your storage. That those 1 to 16 inches become what we call a cluster. A compute instance is running in serverless V2 is defined in size by what we call ACUs, Aurora capacity units. Essentially, an Aurora serverless V2 instance can scale from anywhere at a bare minimum of 0.5 ACUs all the way up to a current maximum of 128. An ACU, as it grows, what we do is we add both memory, CPU, and networking resources along with the ACUs. As you can see on the screen, an ACU is approximately equivalent to about an additional 2 gigabytes of memory. If you want to think of it in terms of vCPUs, basically the ratio is 4 ACUs is approximately 1 vCPU, or 1 ACU is approximately a quarter of a vCPU. That's a sort of a fair, rough analogy. Part of the magic of serverless V2, again, you don't necessarily need to worry about it, but I like sort of talking a little about some of the interesting engineering things that happen, is in a database, one of the key things that makes a database work well is its use of memory. And the database will try to use memory to reduce the need to do physical I/O, because physical I/O in a database traditionally is your slowest resource. So anything you can do in a database to move stuff to memory and less on I/O is a win. And databases, however long they've been around, Oracle for 40 years, MySQL and Postgres for 20 and 30, have all been building more and more of their code around these memory structures. Well, if we're going to offer a serverless V2 instance, we have to think about memory. And so some of the clever things that are actually in the internals of Aurora Serverless v2 is making things like buffer pools dynamic so that we can change them on the fly. Typically databases, you would allocate the full extent of the buffer pool based on a parameter when you start the database, and you would have to stop the database and then restart it to change it. But with Serverless v2, we actually will grow and shrink the buffer pool on the fly in coordination with all the various running processes of the database. And this is a really interesting problem and a really complex thing. Growing the buffer pool is not that hard. The fun work is when we shrink it down, because the buffer pool is going to be filled with data. So what we do with Serverless v2 is we sort of have to work with algorithms so we can, at the right moment, make sure that some of these blocks in the buffer pool are indeed sort of cold and not needed to be used. And then we can evict them, reorganize them, and free up the buffer pool so that we can shrink the physical memory of the compute instance back down. I mean, this might be more than you want to think about at 6:30 in the evening, but this is sort of some of the magic of Serverless v2 is being able to not just add CPU, but add and remove memory from internal structures of a running database as it runs. All right. A few other things about Serverless v2 that are interesting is we can do what we call mixed configurations, where you can have sort of what we call provisioned instances. These are the ones where you tell us an exact size, like a DB R6G 4XL, and serverless v2 instances all in the same cluster. In this picture, the writer instance is a provisioned instance, and we see two readers in the cluster that are serverless. We could do the exact opposite if you want. You could have the writer be serverless and have readers be provisioned. You could have them all provisioned. You can mix and match. We're very flexible in that regard. In fact, people will use this flexibility as a way to transition into Serverless v2 from clusters that were originally built with provisioned instances. Here's an example of sort of how Serverless v2 can add value. What we're looking at here is a snapshot of a workload as seen through our Performance Insights tool. So those of you who might have used RDS might know Performance Insights, so these screens might look vaguely familiar. But what this is basically doing is it's showing me a workload running against the database, starting, say, at 6 o'clock in the morning, going through, roughly 2 p.m. In the day, at least in UTC time. And we're seeing what's happened in the database. Green means that there's sessions, and greens also means running on the CPU, essentially running without any wait events that are slowing down. So green, CPU, good, typically in the database performance world. The height of the bar just means sort of the number of sessions concurrently that are at that point in time, because we're constantly sort of looking at the database, snapping it every 5 seconds, take a point of view. But at that instant, taller bars mean there's more different concurrent sessions all doing that type of work, CPU work. CPU is good, that's fast. But right around 11:30, you can start seeing these blue bars appear. And blue, according to color code, means data file reads. So for a database, that's a sign that we're having to, instead of doing things in memory, we're now having to go read stuff off disk. So having been in the database world for a while, the most likeliest explanation I can tell you is right around 11:30, what's happening is the block buffers of the database are sort of so full they can't fit any more data, but yet the application's asking for more data. And so instead of being able to retrieve it out of memory, the database is having to go to disk, a slower, more time-consuming operation. So just looking at this chart, it's a shame we don't want to see that blue if we don't have to. And right about 11:30, with this instance, provisioned instance, it started happening. So most likely, just the amount of memory you get with a 4x large was just a bit too small starting around 11:30. If we zoom in, and you can hear the graphic sort of dragging across that little bump from 11:30 to 12:30, the zoom in, what this is sort of showing us is just that bump in detail emphasizing, we're now getting sort of slowdowns in the database, or more wait events specifically for this physical IO than we were before. We also, on this workload, had the benefit of running a sort of what we call a canary query. And what do we mean by canary query is a lot of people will write a real simple query against one of their application tables and just run it constantly and measure how long it responds, and sort of like a canary in a coal mine. And if you ever see it getting slower, well, it's a good sign that other things in your application might be getting slower. So you would build alarms or metrics off how long this identical query runs, throughout the day. Here we're seeing that as these wait events started happening, the blue data file reads, the length of response time for this canary query in the application started getting bigger as well, going from, maybe a third of a millisecond now up to as big as like 3 milliseconds. So we're seeing response times get longer and slower. Again, another sign that we ran out of resources on our provisioned instance because it wasn't necessarily sized that big. Here we took the same workload, but we ran it against a serverless V2 instance. Serverless V2, you can configure things like a minimum ACU, a maximum ACU. What you see here in this chart is you see this dashed line. That's sort of showing you the amount of ACUs that were allocated to the serverless instance. And clearly, I can tell they set a minimum ACU corresponding to sort of the horizontal line. You see right around, I guess, 12 sessions or so, or 12 vCPUs or so. But when we hit 11:30 and we started feeling memory pressure, notice what the serverless instance did in terms of size. It started to scale itself up, and it's a bit reactionary. You have to wait for the traffic to appear. It can't read the human's mind and know that they're about to click on the website. But as soon as it appears, it reacts rather quickly. There is that initial memory pressure where there was some physical reads, but by growing its resources, those rather quickly, that blue compared to before went away, and we had more memory and other resources to work with, returning the application back to its sort of healthy state where it's not relying on as much on physical reads. When the workload burst sort of around 12:30 dissipated, you can see the serverless instance realizes that and starts freeing up resources and going back to the user specified minimum ACU. Here's a chart of that canary query. The line in blue is running on that original provision instance, which was like an R6G 4x large in this example. And the line in orange is running on the serverless. Smaller, less tall lines are better. And so what you see here is for the serverless instance, right at 11:30 in that burst, it got big, but then it reacted, which is what we want with serverless, and gave it more resources, and we went back to sort of the nice predicted sort of minimal latency response time for the canary query. Three sort of interesting new innovations in our Aurora database, zero ETL, serverless V2, and manage blue-green deployments. Now, I'm sure not all of you are database centric, but these are, in my world, pretty cool things. Before I turn over to Varun, are there any questions about these innovations, Aurora or RDS in general? Well, I'm not hearing any questions, so Varun, I might stop sharing and turn it over to you.
All right, thanks, David, and thank you for the deeper insight into the innovations. So let me
Thanks, David. That was awesome.
share my screen.
I can see it.
Okay, perfect. So let me see if I can move this. Around here. So I know today I'm just going to give you a demo, and I think I really like this feature, and I've been into these positions where I have to copy data, where my data warehouse has been, in Oracle, sometime in SQL Server, or Redshift and other places. So I had to use like tools like Informatica, and work around with the magic, play around with those pretty graphs and everything. But still, like, I struggled. Sometimes those ETL processes would break down and things would happen. So I think this is a pretty cool feature. And if you look at the announcement, so I have this announcement here. Earlier, it was in a private preview. So this is a brand new feature that we are displaying here. Still in preview, but now it's in public preview. So if you do go to your console, you're going to see that. But if you see, the announcement came in June, and now we are in the early August. So it's close to 1 month it's been there for the public preview. Definitely recommend taking advantage of that. So there are certain use cases would perfectly fit into that, and I'll go over those use cases also along with the demo. But just to give you an idea, right now it's available for MySQL 3 version, which Aurora calls 3, which is compatible with MySQL 8. And then the region where it's available is Ohio and North Virginia, US West, Asia Pacific, and Europe. My demo is going to be, I did all my demo and everything in the Ohio region, but if you are used to working under the US East one, definitely recommend doing there as well. Couple things. There is a guide, and I think either myself or David will post a link in the chat in case you want to try that out. And again, it clearly says it's in preview, so eventually it's going to go GA pretty soon. I don't have the time right now, but I'm hoping it'll go GA pretty soon. Just to go over the architecture here, I know David touched upon it. The whole idea is you have your Auroras, and then without having any tools in between, you are accessing Aurora data in a near real time with a few seconds of latency into the Redshift data warehouse. And then you can run your analytics queries, and you can do your ML models and everything. So you're completely kind of cutting the middleman here, and just doing like almost like real-time queries here. Just to talk about benefits again, here, the benefits, I think it talks about the use cases here. Let me just go to the next one. Okay. So these are the benefits actually here. So it helps you derive holistic insight from multiple data sources. We saw like Aurora there, and multiple Aurora databases. And then you can remove the complex data pipelines. David talked about that, how you build that complex data pipelines and how data pipelines can be eliminated, and you can reduce the errors by doing this zero ETL. you can reduce the operation burden costs. Now, there's another benefit that I felt, I can relate to my experience here, is like people write a lot of like SQL code to access data from the OLTP into the data warehouses. They use some like DB links, or they use some, complex queries, complex join. And obviously, Amazon tried to solve that using federated query as well. But once you get this kind of a facility, zero ETL, and it's there in the Redshift, I think those are also the use cases. You don't need to code all those SQL functions and those queries to built in. And also, when you see the data right away into the Redshift, you can take advantage of Redshift capabilities like data sharing and other good stuff. So right away, when you see the data in the real time, you can share the data, and wherever you have the requirements for, like, for example, the senior management wants to see some near real-time data into the data warehouses, and they are making those decisions, that it's not coming through any batch processes, it's coming right away from the OLTP system. So a couple other use cases that I see apart from that's been listed here. So definitely it's a cool feature that's been introduced recently. The other thing, it goes into the getting started. It kind of goes through the steps. What are the steps you need to do? Configuring the DB cluster parameters, source DB, target DB, and everything. So I definitely recommend going through the guide. But then I'm going to refer to this blog, which kind of covers all these steps in a one document. And again, I'll paste this link as well, which kind of either David can paste it while I'm going through the demo. It kind of goes through all those steps here. Definitely very, very cool blog. I try to follow that as well to build this demo. And I would recommend, in case you want to try this preview feature, you can do that as well. So what they're doing in this blog, they have a bunch of files called ticket, like people going to the concerts, people going to like Broadway shows and everything. So they have a bunch of tables that publicly you can kind of play around with that data set. And then you can get that data into an Amazon Aurora, and then through the storage replication here, you will see the data into the Amazon Redshift. You can use any tool set to your advantage to visualize the data. So here they're giving an example of QuickSight. So what I'm going to do, I got all the tables there, but I did not load all the data. You can try loading all the data. I entered some data manually by myself just to see how the zero ETL was working. And that's how I'm going to show you the demo here. Couple steps here. The step number one is, the first is configuring the Aurora MySQL with customized DB cluster parameter group. The reason why we do that, and these are the parameter group that we need to customize here, because as you can see, we're trying to read from the log here. So there are certain parameters that you have to enable, which is one feature, like 1 is enabled, 0 is disabled. You want to see the bin log format to row, and you have to create a customized parameter. And that's how, using that customer parameter settings, you're going to basically create your Aurora cluster here. So just to show you that, I'm just going to go to my demo for the step one. So here I have the RDS. If you see in the dashboard, I have a DB instance and I have 2 clusters here. So once I click on the DB instance, this is the one that I've used for the demo here, which is Aurora MySQL demo cluster here. And this is the parameter group. So if I go into the dashboard also, it shows me whether I have a custom parameter group here. So I can go to the parameter group here. This is the one that I created, or I can create a new one by using a create parameter group. It'll ask me what kind of parameter you want to use, and I can give a name and I can select the MySQL version and everything here. So I can do that, and that blog kind of tells you how you go about it. So once you create that, if you see here a couple of parameters that blog was mentioning, I'll just select one here. Let's say the Aurora enhanced bin log. So if you see here, Aurora enhanced bin log is set to 1 here. So that's how I was able to do it. I can still edit it and I can make changes to these parameters. So that's your step number one, to create a custom parameter group. And once you create that custom parameter group, once you did that, I think what you need to do after that is to create the Aurora database using that custom parameter group. So here we are trying to create a MySQL 3.03 version, which is compatible with MySQL 8.026. That's the one you need to pick it for the preview right now. And this is the custom parameter the blog folks created, which they're using to create that Aurora database. Obviously, as you see, they selected a template production. You can still do dev and test. I did a dev and test just to save on the compute resource. And then you can follow the same prompt and you can select it. I ended up selecting even an instance size smaller than this in case we want to do that, just for my curiosity. Obviously, we recommend starting small. Cost optimization is one of our big deal for Amazon. So I definitely recommend you can play around with a smaller size instance if you want to do that, and selecting a dev and test here. And once you do select those things, your database is going to get created. So if you see, in my case, I have the database here created with that custom parameter group, and that's how I've used it. I do have an EC2 instance also where I've installed a tool like dbeaver, whatever IDE tool you want to run some SQL query just to see how the data is. So I have installed that as well. But this is how I've created that particular database using that custom parameter. And then I get two endpoints here. One is for the writer and one is for the reader. So that's your step number one. To do that, create a custom parameter group and then create a database using that custom parameter group. Now, the next step, if you see in the blog, they talk about doing the Amazon Redshift serverless. Now, David was showing you the innovation onto the Aurora side, but then there were innovations happen onto the Redshift side as well. So Redshift now has a serverless version as well. And again, Aurora has a Aurora capacity unit ACUs, Redshift have RPU, some similar concept. It has a memory, certain memory, and certain CPU. And right now, I think the preview, you can do it into the non-serverless, but I think the blog takes you through the serverless route. So again, on the Redshift, they're creating a serverless Aurora version, and they're creating a work group, and they go through the process and everything, and then you create a Redshift database. So if I go back to my screen in my console, so I have a Redshift serverless. If you see serverless here, you have to create a namespace and a work group. So the concept of namespace is where all the tables and all the necessary data and everything would be stored. And preview is there where you have the information about your VPC, security groups, and other stuff. So if I just click on that, you can see the preview. It has work group has all your security stuff, your VPC information, endpoint, security groups, and other good stuff. And you create it, it's going to prompt you for this information. And once you go back to the namespace, that's where your tables and the data backups, so anything to do with the data, it's going to be onto the namespace here. So once you do that, once you create that, the other important thing in that, once you do create and you go through the serverless, follow this blog and create the serverless thing, I think very important thing is they want you to do they want you to enable the case sensitivity. The case sensitivity, why they want you to enable it, because we are moving data from MySQL to Aurora, to Redshift, which is a Postgres-based database. The Redshift is based on the Postgres, so the way they treat the cases, it's kind of slightly different. So they are asking you in this blog is to run this command, and you can run this command on your CLI. So I have set up my CLI here where I know I'm giving this command. All they're asking you to update the work group, name of the work group. This is the name of my work group that I gave when I created the serverless, and the config parameter. And then I'm trying to basically say you enable the case sensitivity so that it does recognize that. and it doesn't mess up. So you can run that via CLI. Obviously, for the CLI is our command line interface. You need to set it up, and you need to make sure it has proper privileges to run this command. I did create a IAM user, and that IAM user has a necessary privilege to create that. Let me just go back to my thing here. So here I did went into the IAM and created that user where I'm able to run those CLI commands. So definitely recommending setting that up and making sure you're able to run that. Okay. So this is one of the user I created called 0ETL. And this is the user I'm using, and I gave administrator access. Obviously, if you're going to try this in your organization, definitely give the necessary privileges, the least privileged model, and follow that. And that's how you're going to basically set up that via CLI. So once you do that, as you can see, I'm moving a little bit quickly. So if you do have any question, I can take it up after the chat. I just want to make sure I don't end up taking too much time. So you did create the customized DB cluster parameter. You created a Redshift server, and you updated the server so that the case sensitivity is identified, because you're moving from a MySQL to a Postgres, which is a Redshift database here. Then we need to configure the required permissions. So this blog goes into the required permissions, what you need to set up here. Now here, the required permission, what they're saying is you can create a policy, and you can go through and you can create a policy called RDS integration, and you can create that, and then you can attach it. Now, I personally felt if you're going to do it in the same account, if you're going to do it into the same account where your Aurora and Redshift both are existing, you may not need that, because I did not use it because I was doing everything in my own account. But if you're doing, let's say if your Aurora is in one account and your Redshift is in another account, which is most likely going to be the case for the organization, that's where when you do some cross accounts stuff and everything, that this policy would be handy. And once you do that, and that's an optional step in my case, you create the 0ETL integration. So that's where you go into the Aurora console. So here, if you see the console, well, let's go into the databases here onto the RDS side. Here, if you see, this is where the 0ETL integration is there, which is in preview here. So if I click on this, I get a 0ETL integration. So here, what I have done, I have created 0ETL demo here. But what it basically does, it asks you for two things. It asks you where is your Aurora database and where is your Redshift database, and it does an integration. So I can click on here, and I can give any name to this integration, and I can choose an Aurora DB cluster. So in this case, if I'm going to browse it, I come up with this database here. So I can select that, and I can choose it. And then the destination in this case, again, if you do create that policy, this is going to be handy. If your Redshift is going to be in a different account altogether, mine is in the same. So what I'm going to do, I'm just going to basically click on this drop down and select the namespace. So namespace is critical because that's where your tables are going to be, as I mentioned to you, instead of work group. So I created that. And once I do that, I can select an encryption in case we want to do some customized encryption or anything. Then I can create a 0ETL integration here. So I'm not going to create it. So this is how it got created. And that kind of makes a connection between Aurora and the Redshift in this case. So going back to that screen, doing the 0ETL integration, specifying things, and they're asking you to create a role, again, different role ID and everything. Again, if they are in two different accounts, you can follow this blog. It kind of walks you through that. It kind of gives you an option how to do it, how to create a policy, how to create a role, and how to do that. Now, once I do that, I have to then make sure that I have a database which is connecting to that 0ETL, that namespace that I created. So I'm here, going back to my screen, and I'm going to the Redshift here, and this is my preview namespace. So if I go into this one and I say query data, I have to make sure in my Redshift preview, I have Aurora 0 ETL that's gonna appear. So there is a command here into the blog that kind of tell you where you do that. You know, on the Redshift serverless, navigate to this thing namespace, choose query data, and that's where you connect to the 0 ETL target. So you can connect that. You specify the database names, which you're gonna specify in the very beginning when you do that, and then you create a connection. Now it does go through different integration ID that you need to find. So what happens when you create the integration between those two using that Aurora RDS preview, it'll make an entry into this table. So when you do this, select integration ID from SVV integration. So in my case, it was this command. So I ran that. So it's going to give you an output. So what you have to do, you have to copy this value. And this happened when I went into Aurora, when I created the 0 ETL integration. So you copy this value, and then what they're asking, obtain that value, copy this result, and then you create a database, Aurora 0 ETL from integration. So you're creating a database into the Redshift called Aurora 0 ETL, which is a database that's linked to your Aurora while you're sitting onto the Redshift side. So this is what I did here. So I gave that command, and then this entry appears under my serverless. So these are by default. The dev is by default, catalog is by default, but this is the entry that starts appearing into my that. Right now I didn't have a demo DB, but it was just 0 ETL and the public. So that's all the entry I had. So that's how the Aurora 0 ETL, which is kind of linked to the Aurora side of the things, appears in your Redshift. And then what it's asking you, this blog, is to load the data from the ticket data set. Now, what I did not go through these steps just to make it easier. There is an HTML file that they provide you here. So I went into the HTML file and I went into the Aurora side and I created these things manually, these commands manually. So I ran that. So let me just show you that. So I went into like a dbeaver tool. As you can see, I'm connected to Aurora here. So I ended up running those commands manually onto the SQL prompt, and I ended up creating this. So I ended up creating like demo DB here. I'm just going to refresh it. As you can see, by running those HTML commands. So let me minimize this. It creates a bunch of tables here, users, venue, category, and other things. So I kind of followed those just for my demo purpose. I just created those tables manually. So I played around with one table here, the user table here. As you can see, I have entered these 3 entries here. Now, if you see onto the Redshift side, so if I run this query, I see the same 3 entries, like 1, 3, and 4. The number 2, Varun 2, is missing here. And if you go back to the source, which is saying Varun 2 is missing here. So what I'm going to do, I'm going to enter that after we have gone through all the block steps. I'm going to add a row, and I'm going to say this is 2, 2. So right now we had 3 records there on the Redshift side. So I'm going to just say test xyz.com 3333, like sports, yes, yes, theater, yes, everything is yes. Okay, and what I'm going to do also, I'm going to make this Varun 4 to Varun 44. So not only we are adding, we are also updating. So we'll do the save, and I'm going to do the save here. So now when I go to my this one, so if you saw on the Aurora side, I made an entry too, and I made a change to this one, Varun 44. Now, if we followed the block correctly, if we follow all the steps correctly, and if our integration is working fine, as you saw here, if our integration is working fine and you were able to enter the data, this goes into all the other data entry. It kind of gives you, in case if you do get some errors, you can rectify. Honestly speaking, I was just having problem with data loading. But overall, if you do follow the steps, I think you should be good. So if you did follow all the steps, if you just go to the higher level steps all the way, if you configure the database with the right parameter, the bin log is working and the logging is working at the storage level. You read the serverless destination with the required resource policy for his namespace. I think there is all the steps that you followed. You enable the case sensitivity and you configure the required permissions. Like, as I told you, 0 ETL user I created, and that's how I was able to create those case sensitivity. And I created the 0 ETL integration that makes an entry into the Redshift, and I selected that SVV integration table, and then I created a database using that integration. If you follow these steps, I should see those two rows appear. The rows 4, 4, and 2 should appear into the Redshift side in a few seconds. So let's take a look at it. 3 rows. I'm going to run this. And here you have 2 and 4, 4. So this one I updated, this one I introduced. So you're getting a 0 ETL response right from Aurora. What you're doing in your OLTP, you're getting into your data warehouse. So that's the overall demo. I'm gonna take a pause here. If you have any question for me, unfortunately, I was not able to watch the screen if people had any questions. So, but let me stop sharing so I can see it. Unfortunately, my
I don't
screen.
see any questions in the chat, Varun.
Okay.
So I think we're currently questionless. Sort of like serverless.
It's like so.
Yeah.
Because
Okay.
you guys demoed it so well, everybody's left without question.
Okay. That's
Totally
good to know.
straightforward, but very interesting. Thank you.
You're welcome. So again, David, were you able to post those links into the chat?
I have. I put
Okay.
the documentation links and the blog link.
Okay. I'm gonna just to reiterate, just follow those links. Again, very, very cool feature. We are very excited from the Amazon perspective. I think it is a game changer for us just to do a 0 ETL. And a lot of folks, a lot of customers are looking for this feature because they want to see the real data, the real-time data into the data warehouses. A lot of upper management, senior management run their dashboards and everything, want to make immediate decision. They're like, the data might be 1 day old or maybe an hour old, but this is like within like less than few seconds. Like I entered and I counted, like sometimes I would count like 5, 4, 3, 2, 1, and I just see the data. So it's kind of like 0 ETL near real time that you're seeing it. And that's the demo I had for 0 ETL. So I'm gonna just stop sharing and happy to take any last minute questions if you have for me and David, or thoughts about it, or anybody has any perspective based on what you saw today.
Thank you both. That was really awesome.